Acid-base calculation in a nutshell. So how do you do the number crunching involving acid and bases? It kind of piggybacks with the stuff you did for solutions, so it's not even completely new. So using concentration to determine acidity, first off, concentration and acidity are connected. If the concentration of hydronium is larger than hydroxide, you're acidic. If hydroxide is bigger, you're basic. So basically your cutoff is basically, or your determining factor is which one's greater, hydronium concentration or hydroxide. And from there you can determine if you're acidic or basic. The cutoff for this is this number. Whichever of the two, hydronium or hydroxide, is greater than this, that's what your solution is going to be. If they're equal to this, you're basically neutral. So if hydronium, for example, is 1 times 10 to negative 6, then that means your solution is acidic. Why? Because negative 6 is bigger than negative 7. Remember, negatives work opposite of what you think it would. So this would be considered acidic. And same time, if hydroxide was bigger than 1 times, let's say it was 1 times negative 4, for example, you see this is bigger than negative 7, your solution is basic. So basically what you're going to do is whatever concentration they give you, related to 10 to negative 7 is bigger than that, then you are basically going to be that. So if hydronium, if it's greater than, it's going to be acidic. If hydroxide is bigger than, you'll be basic. So what would be the opposite? What if you have 1 times 10 to negative 8? So let's say I just gave you hydronium's concentration is 1 times 10 to negative 8, and say, okay, is this acidic or basic? All you have to do is look at it and say, okay, well, this is smaller than this, so my solution should be basic. Because it can't be acidic, right? The only way it can be acidic if it's bigger than this. If it's smaller, it's automatically basic. So the concentration is exactly 1 negative 7. You are neutral. Different ways of representing concentration. One of the most common ones is brackets. So when you see brackets, it's basically telling you that's the molar concentration. So the number inside is your concentration. So that tells you you have a 12 molar concentration. So whenever you see brackets around a number, assume that's your concentration. So here's another visual for the hydronium and hydroxide. So if they're equal, you're neutral, right? If hydronium is bigger than negative 7, like it is here, you're going to be considered acidic. And if hydroxide is bigger than negative 7, you are basic. So negative 7 is your cutoff. So relating hydronium and hydroxide, you can figure out the concentration of either if you have one of them. So the relationship is based on this formula. So if I have hydronium, I can figure out hydroxide. If I have hydroxide, I figure out hydronium. How? Whatever number you're given, take 1 times negative 14 and divide it by the number that you're given. That's the way the math works. So hydroxide of a solution is 1 negative 3. So to give me hydroxide, so to figure this out, right, I'm going to take this and put it underneath. I'm going to divide 1 negative 4 by 10 to negative 3. So when you do that, you get this. And then plugging in the numbers, you get negative 11. You can do this in your head. Remember, subtracting when you're dividing. Negative 14 minus 3 gives me 10 to negative 11 molar. So I can figure out the other one if I have 1. You can see this is smaller than 10 to negative 7. So your solution here is definitely basic. You can determine that ahead of time, right? You look at this like, oh, hydroxide is negative 3. That's bigger than negative 7. So I'm basic before I even start doing any number crunching. So that's what you could do inference-wise. So solution with hydroxide negative 4, acidic, basic, or neutral. I don't even have to do any math. This is bigger than negative 7, so I'm definitely basic, right? But let's do the number crunching just for fun. Like this. So, sorry, I got to do it. We'll do it here. So H3O plus is equal to 1 times 10 to negative 14 divided by what you're given here, which is 1 times 10 to negative 4. So you get 1 times 10 to a negative 10. So hydronium is negative 10. That's definitely smaller than negative 7. So you're definitely going to be in this situation basic. Which you're going to determine without even doing the number crunching, right? Hydronium, when OH is that, so same setup, right? We just take negative 14 divided by 5 times 10 to negative 9. And we get 2 times 10 to negative 7. You can do this in your calculator by dividing 1 by 5. That's going to be basically going to be 0.2 times 10 to negative 5. Put this in scientific notation, 2 times 10 to the negative 6. Or you can do in your calculator if you're used to the whole exponent function on your calculator. All right, pH scale. uses concentration of hydronium to give you a number between 0 and 14, in which tells you if you're acidic, basic, or neutral. So formulas pHs for pH is this. So if I want to figure out the pH, I need the hydronium concentration. It's going to be the negative log of that number. So if the number is 7, I'm neutral. If the number is less than 7, I'm acidic. If it's greater than 7, I am basic. Those are my three options. So the number I get from this calculation, so to do this, I need hydronium concentration. So what if they give you hydroxide? Well, figure hydronium from hydroxide, then plug into this formula. And the way the number crunching goes, you put the number, press log, and then flip the sign in your head. You don't need to put the negative sign unless you really want to. So when you do the math of log of this number, it'll give you a negative number. Negative times negative gives you a positive, so that's why the formula is written as is. So here are some different pHs, blood, pure water, milk. So you can see milk is actually acidic. A lot of people take milk when they have upset stomach, and you can see it's not a good idea. So upset stomachs are usually caused by having too much acidity, so adding more acid is never a good idea. Pure water, which is distilled water, is neutral. Blood is slightly basic. Ammonia, cleaning products are always basic. You can see your acidics are some of the things you've consumed. All right, acid-base strength and pH. Weak acids have a pH around 3, while strong acids have a pH around 1. So there's your cutoff, 3 and 1. So if you're around 3 or above, you're going to be considered weak acid. If you are around 1, like 1.5, maybe even close to 2, you're considered to be a strong acid. Weak bases have a pH around 11, while strong bases have a pH around 13. So you can see the division is basically two numbers. Once again, 2 digits. So 13 is considered, 13 and above considered really strong basic wise, and then less than 11 is considered, or 11 is considered weak. All right, so understanding pH at a microscopic level. So here is your acid and base. You have an individual undissolved molecule, undissociated. And the reason it's undissociated, it's a weak acid, right? It partially dissociates. So if you look at it carefully, only one of them broke apart. The rest stayed together. There's actually, this was connected. Slightly. This one was kind of separated too. So here you have 2, actually 3. So 3 out of all of these broke apart. The rest stayed together. So unless it's complete dissociation, you are a weak acid. If this is complete dissociated, strong, anything below that is considered weak. So anytime you have any molecules together inside the solution, you know you have a weak acid. So that's your characteristic you're looking for. You're looking for a compound. Anytime you have a compound, you are considered a weak acid. Even if it's just one compound, it's still a weak acid. So be aware of that. All right, pH values. Here's some common ones. Battery acid. This is why you don't mess with the battery in your car. And we're not talking about your 9 volts or anything. Those are not considered really acidic. They're acidic, but not to this extent. Battery acid is basically made out of sulfuric acid. That will burn through you. So don't mess with your car battery or a car battery. Stomach acid is around 2, apple juice around 3, black coffee, pure water, and you go on to your cleaning products and their acidity. Calculating pH, once again, it's the negative log of hydronium. Calculating pOH is negative log of hydroxide. pH plus pOH equals to 14, which we'll use in a second. So hydroxide of tomato juice is 1 to negative 10. What's the pH of the solution? So first thing we want to do, when they give you a question where they don't give you hydronium, the fastest way to figure out your pH is doing this. Instead of doing figuring out your hydroxide using this formula, 1 times 10 to negative 14 divided by 1 times 10 to negative 10. You could do it this way, get your value, which is going to be 1 times negative 4. You plug it into the pH formula to take the negative log of that, get your value. But the easier way of doing it is do your pOH first. So if they give you hydroxide, just get your pOH. So how do you do that? Whatever number they give you, take the log of it, and then flip the sign. So log of this is going to be negative 10. Log, in case you didn't know the way it works, if your coefficient is 1, the exponent is your value. So the log of 1 times negative 10 is just going to be negative 10. And then when you take the negative of that, that's where you get the positive value. Like if I have the log of 1 times 10 to negative 6, your value is negative 6 before I flip the sign with the this part, right? That's only if your coefficient is 1. If your coefficient is 1, you can't do the shortcut, so be aware of that. Only works with the coefficient is 1. Anyway, so it's 10. So then how do I get my pH? Well, we know that pH plus pOH equals 14. So if you know that, if you do 14 minus whatever number you get for the pH or the pOH, you get the other one. So in this situation, I put my pOH here. So 14 minus the pOH gives me my pH, which is 4. That's the easiest way of doing it. Though you could do it the other way I just showed you by doing the hydroxide concentration to hydronium concentration. And sorry, this should have been, because they're giving you hydroxide, this is going to be H plus that you're looking for, not hydroxide, because this is your hydroxide here. So you get your hydronium concentration or H3O, they're the same thing, remember. And then do negative log of it, and then get your answer that way. But I think the easiest way of doing it is just take the log of whatever they give you, and then subtract it from 14 to get your actual value for pH or pOH, depending on which one they're asking for. All right, methods for determining acidity in lab. Litmus, which is an indicator, you may have used in your biology class. It's a piece of paper. It turns either red or blue. If it's red, it's acidic. If it's blue, it's basic. Phenolphthalein, which is an indicator that is pink when basic and clear when acidic. That's the most common one to use for titration experiments. And pH meter. And that's the most accurate, and that's what you'll probably be using for your labs is pH meter, because it gives you much better data and gives you exact value. And this thing here is the universal indicator, which changes color based on pH. An example of a universal indicator, by the way, is you can use cabbage juice, purple cabbage juice. If you try to blend it and then just take the juice, it will also give you different colors based on pH. A little fun fact. The problem with using an indicator like this, really hard to distinguish between colors unless you have supervision, right? So that's why it's not as accurate. You can kind of ballpark it, like if it's purple, you know it's basic. If it's one of these colors, it's acidic, but distinguishing between pH of 1 and 2, for example, really difficult. So that's why we typically don't use universal indicator for this stuff, because it doesn't give you the best data points. But it gives you acidity or basicity. The best thing to determine exactly your pH values is a pH meter. All right, lemon juice has a hydronium of that. What is the hydroxide of the solution? So same concept. We use our formula for this. We know that the 2 together goes to 1 to negative 14. I'm going to solve for hydroxide because that's what they're looking for. 1 times negative 14 divided by 2 times negative 3. In your calculator, you get 5 times negative 12. There's hydroxide concentration. Now, if they're asking for your pH for this, by the way, pH would just be equal to pH equals negative log of 2 times 10 to negative 3. And if you're asking for pOH, you can get this, subtract from 14, get your pOH, or your pOH can also be solved by this, negative log of 5 times 10 to negative 12. Both ways work. All right, some final questions. Determine if the solutions with the following information are acidic, basic, or neutral. So first one, this is smaller than 10 to negative 7. So that means you definitely aren't basic. So this is going to be acidic, right? Because this, which is hydroxide concentration, is not bigger than 10 to negative 7. Turn pink. Pink is usually a sign of bases. pH of 7, you're neutral. This is bigger than 10 to negative 7. That's hydronium's concentration, so that means you are acidic, since that's winning the contest. Blue, that's going to be basic. Orange juice, citrus, all citrus fruits are actually acidic. pH of 9, hopefully you remember that's basic. And turn clear with phenolphthalein, that's going to be consistent with acidic. So that's how you do calculation regarding acids and bases.